Yo, what's up, everybody? Back with another video. I'm sure, as you guys may have seen, I am setting the bike up for methanol this time around. It's either, go big or go home. So, setting the bike up for methanol. Actually just got some parts in the mail not too long ago. First, I would like to shout out Tom Sewell over at Fuel Injector Development. Makes some really badass injectors. Very knowledgeable guy. This is my second time running his injectors. I actually ran his injector with my last EcoBoost setup, and it ran pretty good for the most part. This time around, as you guys know, I'm running a dual injector setup. So once again, I'm running two of Tom's injectors. This time around, I am running a 77-pound injector and a 208-pound injector and a 77-pound injector. So you can see these were sent with all the injector data that I need, and pretty much this stuff will go in the fuel tech. So you can see the flow rate at the base pressure, and then the dead time at whatever base pressure and voltage you're running. So this is all good stuff. Very good information. All of this stuff will be input into the fuel tech. And then what else? I am also running two of the billet speed injector holders. Shout out to those guys as well. So these injectors, or this injector, is pretty much LS3 based. So you'd find something like this inside of a or on a LS3 or 6.2 liter Camaro SS. Really short, stout injector, super compact. And then this injector is actually based off the stock dimensions of the Yamaha YZ450 injector. And the reasoning behind doing that is actually because, as you guys saw in my other video, I have the KTM 390 Duke throttle body, and this is something I actually just modified a few days ago. So let me grab one of these. So on this throttle body, I'm actually using one of the stock injector port, and you can see when I insert this in there, see if I can do this one-handed. It has quite a bit of depth in the injector port. So I actually had to modify this injector hole a little bit, or I'm sorry, this injector holder a little bit. I had to cut some of this material away right here because I wanted to get the right protrusion into this port right here. And that was more so because this is my primary injector. This is actually the 77-pound injector. And the reasoning behind that is because I just didn't want to, disrupt drivability of the bike. I wanted to try to maintain as stock of an injector angle as possible. I mean, even though I am running a different throttle body, but it's always better to, try to stay consistent with that stuff, with setting it up just how it was stock. So, and then as far as the secondary injector, which is a 208-pound injector or 2200 cc, I actually just drilled a hole in the side of this throttle body right here, and I had to grind this and cut it at a 45-degree angle. Still got to clean it up a little bit. This was just more so for mock-up, but I could put this one up here and you guys can see what I'm talking about. All right, let me see. Okay, you get on there. All right, so you can kind of see how that one is in there. Sorry, I can't really get this butted up close with one hand, but it's at a pretty nice angle to where, fuel isn't just spraying on the interior wall of the throttle body. It's actually a nice straight shot into the intake port. So that works pretty good. Pretty happy with the way that turned out. And then besides the injector and the throttle body, I also just picked this up. Shout out to John Gentry, got me together on a couple of fuel tech items and an AEM ethanol methanol pump. So this is a bit overkill for what I'm doing, but just out of all my years of messing with cars and stuff, I figured out that you can never go too stupid on a fuel system. It's just one of those things where it'll just benefit you in the long run, because no one will want less power, and you need more fuel to make more power. So this is a AEM in-tank fuel pump that is compatible with gasoline, ethanol, and methanol. It's rated for 245 liters per hour at 40 psi. So this is way overkill for what I'm doing, but yeah, I'd rather be safe than sorry. Only thing I'm a little bit worried about is if the stock stator on my bike can handle this, because I want to say when you really start getting into the boost, this thing pulls quite a bit of current. I think it's almost like 9.5 amps. So yeah, I'm a little worried about that, but I mean, I guess we'll just see what happens when we get there. So anyways, so I already got the stock tank apart. This is actually the stock fuel pump right here, stock fuel pump and filter. And then this is the stock fuel pump basket. So this will have to be heavily modified, because if I put these side by side, you actually see it's quite a difference between these pumps. So I think it'll fit. The only thing is I might have to, instead of running it straight up like this one would normally sit in here, like that vertically, I might have to hack a bunch of this off. I know this lower piece is going to go bye-bye for sure, because I need to try to get this pump as low as possible in this basket. But I might have to tilt it at a slight angle like this and mount it in there 45 degrees, so that way it'll clear the actual roof of the tank. So I might actually try to get this mounted today. I'm gonna Dremel a bunch of this crap away, and I'm gonna see if I can get it mounted. One other thing that I also had to pick up is this in-tank submersible safe ethanol methanol hose, and I actually picked this up from Racetronics. These guys are also big in the aftermarket with fuel pump hot wire kits and all of that stuff. But it's important to note that you cannot just put any type of rubber hose inside of a fuel tank and submerge it. It actually has to be rated for it. I mean, I have in the past, and it probably wasn't the best decision, but yeah, it's even more so important when you start playing with alcohol-based fuels like ethanol and methanol. So I wanted to be safe about that. So I actually picked up about 1.5 feet of that hose. Racetronics sells it on their site. If you want to buy this, I can actually give you the link, or I'll probably just include it in the description. So anyways, I got to try to get all this stuff to fit. Willing to do what I have to do to make this work. And then I might try to step up this gauge wiring too. I might actually pick up some tad bit thicker wire and some stouter terminals, because this stuff is actually corroded a good bit, and I'm sure that's probably because I was running E85, and it's no fault to Yamaha at all. I mean, it wasn't set up to run ethanol. So, yeah, let me put the camera down, whip the Dremel out, put a tip on it, and start hacking away at this, and we'll see what turns out of it. So, yep. So I have the stock fuel pump out. For the most part, I actually ran the stock pump even on E85. This is just more so like preventative maintenance, because I don't want to do this down the road, so I'd rather just address it now and put something in there that'll handle the horsepower that I want to make on the new setup. So this is a stock pump. This wiring is also coming off because I'll be upgrading to I forget the actual name, but it's, you know, rated for ethanol. It usually comes on the Walbro pumps. I know the Walbro 450, the E85 compatible one, has it, but it's a noticeable difference in like wire sheathing. That's you'll definitely notice a difference between like a cheaper pump and what I'm talking about. So as of right now, I'm looking at the Walbro, the AEM 225. Only thing I'm a little nervous about is that pump draws more current than I'd like to see. And that's like one reason why I tried to stick with like a low base pressure as far as fuel pressure goes, because it, you know, it's less load on the pump, so in turn it draws less current. This will be going bye-bye. This is really the, I mean, other than when I took it apart the first time to plug up this fuel pressure relief valve right here, which is very critical. You will literally burn up your motor if you do not plug this, because adjustable boost reference fuel pressure regulator is pretty much irrelevant as long as this is tied into the system. So you can see mine is welded right there. I would not recommend doing that. There was a small fire, but anyways, that's a story for another time. But yeah, actually looking at this a little bit closer, I'm actually just ditching this completely, because this is just one more leak in the fuel system that can occur, like if one of these seals let go, or if I push it to a fuel pressure that this plastic can't handle. So I mean, I won't be using this anymore, and this will also make it a little problematic for fitting the new AEM pump inside the fuel basket. This will need a lot of modifying, but I think I can get it to fit. So this is the stock pump right here. Like that background. But yeah, all of this will have to get cut. I gotta take a Dremel and basically drill or grind all that stuff down till I hit the floor. And more so of it is because the stock pump is, oh, that turned off. So yeah, so the stock pump is 95 millimeters. I know that's reading negative, but it turned off while it was at the measurement. So stock pump is 95 millimeters from the base of this, the top of this filter bulkhead right here to the top port. The new AEM pump is 113 millimeters from base to tip. So I have to buy myself some room. I just measured the bore of this until I hit the floor to where the stock pump bottoms out at, which is this like ridge right here. And I have about 30 millimeters of space, so that's quite a bit, and I think it'll be enough to buy me room for the new AEM pump, while still also having room for you know, the hose that'll be on top. So and then instead of using this interface, because the stock fuel pump seal actually it actually rests in that bore down there. So instead of dealing with this and a freaking O-ring, I'll actually just put a hose on the barb of the pump, and then just run the other side of the hose straight to here, which is the outlet fitting, which is also a AEN quick disconnect that I'm running now. So it'll just make it a lot more simple. I'll probably retain some of this right here just to, you know, give me something to fasten the pump to. Probably just drill 2 holes and run like a metal zip tie through it, just so it stays stationary and doesn't bounce around. And then, like I said, all of this stuff right here has to get ground down completely. So, and then obviously the new wiring. I'm gonna get rid of this stuff. All right, so this is pretty much the finished product. I will say that this zip tie, I'm not leaving that on there. This is just more so for mock-up. When I actually put this thing together for the final time, I'll actually just use like one of those DEI steel cable ties instead, or the stainless cable tie. But yeah, it actually worked out pretty good. Like I said, I did add material in this area from this piece of the fuel pump that I got rid of. Just checked it with some water and let it sit for about 20 minutes and 0 leaks at all. So it must be good. I'll ride with it. Yeah, this is yeah, I'm actually pretty happy with the way this turned out. So yeah, I just got to pick up some steel cable ties tomorrow, get some new wire because I want to change these terminals, and then clean all this corrosion off right here. And yeah, we should be good to go. And then next I could just start on plumbing the hose from this fitting to this fitting right here and make sure there aren't any kinks or anything. So yep, I'll record that when I do that as well. So yep, just give me a few. All right, so you guys can see I got the injectors wired in. If you really pay close attention, you can see these are actually 2 different configurations. So the stock YZ injector actually looks like this. It has like this extended tip on it. So this piece actually is still part of the injector. Funny part is this actually looks like a DI injector. They look really, really similar. But anyways, so that is my 77-pound injector, or my primary injector. And then this is the 200 and I think 208. Yeah, it's 208, 208 pounds, 2200 cc. Both of these are from Fuel Injector Development, but this one has a traditional injector tip on it. This is a Pico size injector, so it's really similar to like what you would find on like a LS3 LS engine OEM injector setup. The reason I went with this one though is because since I'm running this aftermarket, or I'm sorry, not even aftermarket, it's KTM Duke 390 throttle body. So it's a drive-by-wire setup, electronic throttle body. I'm actually retaining the stock injector port. So I'll basically just take one of my, man, I really didn't plan this out good. I'll basically just take this billet speed injector holder and weld it to this hole right here. Because the stock KTM setup, it uses like a press fit, like a nylon hose. I don't even think it's nylon. I don't know what the material is offhand, but it's something I wouldn't trust to, you know, run like an elevated fuel pressure on. So I went to these setups because this is like a lot more robust and set up for what I'm trying to do. And it gives me a little bit of flexibility with mounting and ease of like, you know, taking the injectors out if I want to get them clean before I put the bike up for the season, which will probably be never. So anyways, so this one right here I actually had to modify because, like, as you can see on this injector, that injector is shrouded a good bit by the body of this housing right here, and that's nobody's fault at all. I just gotta, you know, modify it to my application. So this one I actually did, okay, you can actually see the piece right here. So I took this much off of it. This is about 1/4 of an inch. And then I cleaned it up with a file to get it flat again, so there weren't any like burrs or anything. So yeah, that wasn't too bad. But the reason I did that is because with the primary injector, I'm actually retaining this stock hole right here. And if I would have just took this billet housing and welded it straight to it, it would have been shrouded like this one is right here. So that can, you know, it's probably not the best because it can mess up the spray pattern. and that can equate to drivability issues. And I really didn't want that on my primary injector, because I don't, you know, I want this thing to still drive like a stock bike. So I will place this in this hole, and you will see why I did that. So if you, let me make sure it's butted against there. So if you see, with it centered, it is actually looks somewhat stock. So the stock depth on the KTM injector and my YZ, they both have similar injector tip depth. Yeah, so this one is pretty close to the edge of this bore right here, and that's typically what you would want, because like I said, it could really mess up the spray pattern, which could cause drivability issues. So it's little stuff like that you really got to pay attention to. I actually could take a little bit more off of this and get it closer, but I think this will work because this is exactly the depth of the stock KTM injector. So, and that's an OEM setup, so I don't think I'll have a problem. But yep, I basically just did you know, one cut on this, and then I used a file to get it flat, and then I went around the bore of this with the razor blade just so there weren't any burrs or anything, just so it didn't, you know, look like crap. So that will get welded on to this right here. And then the other one I actually have to cut at a 45-degree angle. This is the bigger injector. That'll be staged in under boost. So this one, you can see, is quite a bit recessed. So I'm taking most of this off, and it's going to be at a 45-degree angle. And then, so the throttle body, once I get the V-band welded on, throttle body will actually sit vertically like this. And then the connector will be in the front, and then it'll have two flanges welded on it, or a flange welded on the head and a flange welded on the throttle body, and it'll use a 1 3/4 aluminum V-band. So with it sitting like that, originally I was going to use this hole right here. So this is the stock map hole that the KTM uses, but as you can see, it's at a 90-degree angle, and I don't really want to position the injector like that. I mean, under normal operating conditions, that injector technically will only turn on once airspeed is already in this throttle body. But I would rather have it facing the valve somewhat, just so I don't run into any type of like drivability issues with the tip placement. So instead of doing that, I'm actually going to use this area right here. I'm going to drill a hole right here, like somewhere right in this area right here. And then I will have this secondary injector. Man, I really did not plan this out correctly, because I need more than 2 hands. So it'll be somewhere right here at a 45-degree angle, and then I'll have it welded, but it'll be flipped around so the connector faces the outside. And then what's nice about this setup is that these injector holders from Billet Speed actually have -4AN connectors on the top, so I can get really flexible with fuel hose routing. So I actually want to take these out too before I get debris in here. So I just mounted these just for the video, just to give you guys a reference of what I was talking about. But I'm actually going to pull these out, and then I'm going to cut this one, and then I'll show you how it looks. Kind of see what I'm doing here. Definitely got to do some more file work on this to clean it up, but you can see how much sharper that angle is now. So basically, the more I taper this angle downward and make it like more extreme, it is basically tailoring this injector angle to be more of a, like, you can kind of see, like when I butt it up against this wall, Really can't get it flush because the vice grip is in the way, but actually, you know what? Let me take it out. This thing is probably still hot, so I'm probably gonna burn the absolute shit out of myself. So, but yeah, this is basically what I'm doing, and I'm starting to get this injector angle where I want it. So you can see how it's kind of like pointed down, similar to the OEM injector angle, so like at a 45-degree angle as opposed to being straight like this. So you can see the more I file this and clean it up, it'll tuck closer and closer and basically close this gap up to where it's non-existent. So this is actually starting to look pretty good. This is kind of how I want it. So yeah, so they'll basically both injectors, it'll basically be like a V angle, how the way these are pointed towards the intake valve. So try to make these as symmetrical as possible, but I do have to do, obviously I got to clean up that bore, and then I need to just do a little bit more file work on the face of this and get it flat, and yeah, we should be ready, and then I can drill the hole into the wall of this electronic throttle body and should be ready to get welded. So yep, so let me just clean this up more, and then I'll show you guys the finished product. All right, so I actually mocked this up to the wall of the throttle body where I want to mount it, and you can see I have the injector hole pretty much marked right where I want it, and then that line on the left of it is actually the wall of this right here. So I'm actually about to drill this now and yeah, get it mounted. All right, so got this hole drilled out. I actually elongated this a little bit just to reiterate on the whole shrouding issue. Yeah, I wanted to elongate this so that way whenever this injector activates, it's not hitting like, you know, like a burr or it's obstructed in any way. So yeah, I just pretty much used a drill bit and elongated this hole. And now I will take this, which is the injector, and this will probably be impossible for me to do, but I could try my best so you guys can see. So this is the injector butted up against the wall of the throttle body, and then it's not centered, so it's not centered. Yeah, you guys pretty much get the gist of it, but I do have this centered and it's not obstructed in any way. And then I also took down the edges and the ID of the throttle body just so I don't have to worry about the throttle blade getting hung up, because it actually swings towards the hole that I just drilled. But yeah, this should work pretty good. It's at a pretty good angle, pretty straight shot towards the intake valves, and yeah, should work pretty good. So I'm gonna get this stuff welded up, and then we will take a better and closer look at it. So yep, stay tuned. And as far as the paperwork goes that was sent with the injectors, I'm actually gonna show you guys what I'm talking about as far as like inputting this stuff into the ECU. I actually just threw it in there a little bit ago, but I'll just show you guys.
No ride ready.
That is the Moto gadget that says that every time you boot the bike up. So I'm gonna click in here, go to fuel injection, and then this is basically all of your injection settings as far as anything fuel related goes. So semi-sequential, one output. So the first injector, this is the primary injector, which is that elongated one right there. That is 77 pounds per hour, and they actually rate this stuff in cc's, but you can easily use a conversion calculator to go from cc to pound per hour. And basically 809 cc at 43.5 psi equates to 77 pounds per hour. And then it's all it is just as simple as just hitting these arrows until you get to you know, whatever the calculator spits out at you when you put that CC rating in. Secondary injector, that is the LS3 injector right there on the bottom. Once again, that was 2186 at 43.5 psi. That's what it flows on the injector bench. So use the calculator on that one. That one will also be semi-sequential, one output, and that gave me 208.1 pounds per hour. And then I have two different tunes set up. So this is actually my ethanol tune. So I got ethanol selected as the fuel type. And then this is based off of the injector closing time. And then one more thing I want to show you guys. Let's see, where is it? Oops. Okay, there you go. Injector dead time. And that was something that I referred to when I was talking about down here with the different voltages and pressure. Based off whatever you select, it'll have a different dead time associated with it. So obviously 12 volts, 1.21 milliseconds. Put that in there like that. And then the secondary, 12 volts, 0.71, 0.710 milliseconds. And yeah, it's basically just that easy. All right, this is something else I want to show you guys. This is something pretty neat to note as well. So let me boot up the fuel tech. So fuel tech starting up, got everything powered on. So I just want to show you this neat feature that you have the capability of doing on the fuel tech. So you can see, recognize my ECU. I got my two different tunes in there, one for methanol, one for E85. So we could just load up the E85 one just for reference. I wish this thing would stop moving. So if we go into map and we go into sensors and calibration, scroll down to outputs, you can see all of my like engine related outputs, and the generic output switches are right here. And then if you look next to it, you actually have this like little lightning bolt right here. And what that does is basically triggers that output momentarily. So you can see I have my primary injector right there, my secondary injector right there. And this is a really neat feature, especially if you're wiring something from scratch like I'm doing. It basically just gives you the capability to go back and double check your work and make sure things are like operational once they're wired. So if you see, I'm going to click injector 1 and listen. Click it one more time. So that's injector 1. Injector 2. Injector 1. Injector 2. Injector 2. So that's something that's pretty neat. So now both injectors are validated. I know they work. I know my wiring is correct. So I could check that off the list. And that's one less thing that I got to worry about, you know, when I fire this thing up for the first time. So just something I wanted to show you guys. Pretty neat. This is probably like my favorite part about the fuel tech. Really happy with this FT550. Yeah, no complaints. And then this just made me love it even more once I figured out you could do this. So yeah, just wanted to share that with you guys. You guys might be wondering, how exactly did I calculate the size of the injectors that I needed for my turbo build? So I'll show you exactly how I did that. I actually used Fuel Tech's fuel injector calculator. They just so happen to have one on their site. I mean, you don't have to use theirs. You can easily use like any generic one that you find online. All it's basing its fuel injector calculations around is the max engine horsepower. So in my case, I used 150 engine horsepower as my target. Number of injectors, one turbo motor, of course, and then alcohol or methanol fuel, and then 80% is, you know, that's like a national standard. And it basically gives me 236 pounds per hour. So I actually broke mine in half because I'm using a dual injector setup. That tends to work a little bit better, especially on small CC engines. You just have a lot more resolution, and it just tends to run a lot cleaner if you run a stage injection setup rather than, you know, one and go or a single injector setup. So 236 pounds. My total fuel volume is actually a little bit more than that because I'm running a 77 pound injector, and then I'm also running a 208 pound injector. So I think that's what, like 285 pounds total, if I'm not mistaken. Yeah, this is pretty much how I came up with my fuel injector calculation. And I always tend to overshoot this because you can never go too big on the fuel system. You'll never want less power. I try to stress that with everybody that's in the same boat that I'm in right now. When you're in the building phase, you can never go too big on a fuel system, because I mean, it's just one less thing that you have to change if you want to make more power later. So but anyways, yeah, this is pretty much what I use to calculate the injector size that I needed. And it even gives you the option to have different fuel types selected. So obviously you have pump gasoline, ethanol, and then alcohol. So just figured I'd throw that in there for anyone that was curious. Yeah, so these are actually ready to get welded to the throttle body. I think I just got to go over one of these with a really fine file just to get a few burrs off of it, and it should be ready to go. Yeah, I did mock these up on the side of the throttle body where they're going to be positioned, and you can actually see that in these pictures now.
Within 12 months,
Get both injectors mocked up today. Welding the bongs on. You guys see both injector bongs. All right, guys, so this is pretty much the finished product. So you can kind of see what I'm intending to do here. So both injectors, primary, secondary, 1/8 inch NPT to -4AN 90-degree fittings. So these will have individual feeds. Like I said, I ordered the wrong fitting for this one right here. This is a -8 ORB. So I'll basically, actually, let me grab the fitting. Okay, so I have a -6 to dual -4AN Y fitting. So once I get the fitting for the regulator, this will basically be screwed into that fitting, and then these two -4 fittings, they'll go up and feed each injector individually. So I think it should work pretty good. It's pretty common with like billet atomizer injectors, because they actually make a variant that looks similar to this, where you can individually feed injectors with fuel hose as opposed to a common fuel rail. And that's for really, like, you know, low clearance applications. But anyways, I'm actually getting ready to shorten this. This is the connector for the throttle body. Made this way too long, and I didn't have the correct Tessa tape wire, wire loom tape. I typically like to use the Tessa stuff because it has a much better or a much more appealing look to it when you outfit the harness with it. So I'm gonna get this shortened up. Probably like 80% of this is going bye-bye, and then I'll show you guys what's up. So I got some well-needed parts. Actually got most of the rest of what I need for the fuel system for this thing. So for the most part, I pretty much have, so obviously this is coming straight out of the fuel pump here. So this is the main feed. So this line would actually attach to that port right there, right off the fuel pump. Have some Earl's Ultra Pro line coming up. Then that goes into the actual fuel boost reference fuel pressure regulator. And then got the return there, ethanol content sensor, and then this port right here would actually go to the injectors. So what I'm thinking of doing right now is basically using this return port right here to tie the ethanol content sensor into, and I basically have a set of these. Actually came from Radium Engineering. They make some really badass products, very high quality. I actually want to run some of their stuff on my truck build, but they actually make a low profile 3/8 SAE quick disconnect to a 6AN adapter. And this thing is pretty small. It's nice, tight, and compact. And what I mean by 3/8 SAE, I'm actually talking about this port right here. So you can see how you have a hole right there. Usually it's double O-ringed, which I think this one is. And all this stuff is compatible with ethanol and methanol as well, so that's nice. And then they even have this beautiful anodized lime green locking collar. So this is a really high quality fitting. But typically these, like if you get a 3/8 SAE port or fitting, usually they're pretty bulky, and especially on a bike, space is a premium with this. So I got to try to find as much room as possible with packaging everything, because I don't want anything sticking out past the fairings, because that just becomes another weak link in the chain. So yeah, these are pretty nice. So I'll run these on both ends. Actually, you know what? Let me put it on and I'll show you. All right, so you guys can pretty much see what I'm talking about now. So these double O-ring connectors basically slip on this 3/8 shaft, and then that little raised portion actually is flush with the black part of this fitting. And then you have this locking collar that basically, it has like a little tang right there that uses this like hex portion as a stop. And yeah, these hold up pretty good to high fuel pressures and everything. But yeah, these fittings are super compact, super nice quality too. So shout out to Radium. Glad I went with these. But as far as tying this into the regulator, I also picked up some more Vibrant fittings. Very high quality piece as well. Shout out to the guys at Vibrant. I'm actually running a lot of their stuff on my bike, and I ran a lot of their stuff on my previous build. So once again, very high quality company. But anyways, you can see on the return, which is right here, that has a male 6AN fitting. So since this ethanol content sensor is going to be in line with the return fitting, I picked up one of these female 6AN fittings to ORB. So basically it'll just screw right in the bottom of this regulator. I could just use this male fitting to screw right into this female fitting, and it'll actually act as a mount as well. And I feel a little bit better about it because it's a shorter fitting too, so it's a little bit more rigid than, you know, having a full length AN fitting sticking out of it. So let me get that in and I'll show you guys how it looks. All right, so I got this fitting out of here now. So this is that male AN fitting I was referring to. Swapping it out with a vibrant female ORB fitting, which will screw right into this port, and then this will screw right onto the ethanol content sensor. All right, so I got that one in. This one is also coming out of here. This is the main feed to both injectors, and one of these fittings will also go into here. And now it's actually looking like I got the wrong size fitting, so I got to return one of these and swap it. So that was my mistake. This is actually -8 ORB, and I accidentally got -6 ORB, so that'll have to wait probably until this weekend. But yeah, so this is actually what I was meaning about the ethanol content sensor. So it'll go in line with this, and then I'll have a support on the other side of it, so it isn't just, you know, weight bearing just on the fitting by itself. All right, so done making my modifications. Got rid of that ORB fitting that was originally screwed into the fuel pressure regulator. So now I'm just 3/8 SAE to 6AN with the O-ring screwed right into the fuel pressure regulator. And you can see that fitting is actually inboard now. I can actually play with this bracket a little bit and bring it in a little bit more, but I just wanted it to not be anywhere near this side shield right here, because I don't want to, you know, risk anything getting damaged if I drop the bike. Purpose of this is to make everything drop proof, so I'm doing that to the best of my ability. Also changed out the wiring that I originally did for the throttle body when I was testing it. So now I have a small 6-inch jumper up to a 6-pin Deutsch connector. And I actually did that because this connector that plugs on the throttle body might be a pain in the ass to get to once everything is, you know, bolted in, you know, plenum and everything else that's going in this area. So this came out pretty clean. Got it loomed up, double checked the wiring, everything works perfect. So got pretty much everything done that I wanted to. Still got to do this flange though, so yeah. So now you guys can pretty much see what I was insinuating with the Y fitting. So each of these will break off and go to their own injector. So I'll have individual 4AN injector feeds, pretty much. Then I actually just ordered some fittings from Amazon. Got a 90 female 1/8-inch MPT to male 1/8-inch MPT. Gonna have a 90 in here, sensor screwed in from the bottom, and then that'll also be tucked within this area, so don't have to worry about anything getting damaged. So all right guys, little bit more on the fuel system. I actually got a little bit of a downtime because I actually took my tire off. I'm modifying it right now to put the wheel speed sensor on from the Honda CRF 450L 2019 model. So in the meantime, I figured that I would hop back on the fuel system because I actually got more parts in today. So I actually just finished the plumbing with exception to both injectors. But you can see I am running a 0 to 200 PSI low dollar motorsports pressure sensor, which is this right here. You see the pigtail plug into it. Got a 90-degree fitting on there. And then this is the feed line coming from the tank, -6AN. And then there are both of my injector feeds right here. So that's a -6 to dual -4. Each injector will have dual dash or a single -4 fitting feeding it. Ethanol sensor, that's in. I actually have that capped off right now because this is the return up to the tank. So I'll probably do like a banjo fitting like somewhere right here, or I might even remove this lug and repurpose this area because I do want to keep this shield on here. It just looks a lot more OEM looking, and it just looks better to me with this cover on. That's one thing that I actually like about this bike over every other dirt bike. Just a really clean look. But anyways, so yeah, I got everything plugged in, capped off, and obviously got the fuel pump in here, finished plumbing and wiring that. So yeah, let's see what this thing does. See if it makes.
Low ride ready.
Here's the pump. And we have fuel pressure. The ethanol content sensor is actually plugged in right now, but I do have that teed into a separate circuit. I actually have it teed into the fuel pump circuit, actually. And that's more so to conserve power because, yeah, I want to try to, you know, minimize the electrical load with the bike with the key on position as much as possible. So when the fuel pump's running, the ethanol content sensor actually comes online. That's why you don't see a reading right here. It does work. I can actually take you to pin map to show you. So obviously you can see it is online. Just the 12 volt isn't activated. That powers the sensor because it turns on only for 5 seconds. So it's in tandem with the fuel pump circuit. So anyways, yeah, we got fuel pressure, so I don't see any leaks or anything, so I must have did something right. But yeah, should have my Motion Raceworks package come in tomorrow so I can finish the plumbing on the injectors, which you can see right there. So, yep, should be good to go. And then obviously, like I touched on earlier in the video, let me see, I have both of my tunes. So I got the E85 tune right there, M1 tune. Nice, clean, and simple to switch the map depending on what fuel I'm on. So that's pretty cool. But yeah, that's pretty much the gist of it. All right, guys. Slight edit to the video. I actually got my parts just in time. I actually picked this stuff up from Motion Raceworks. Shout out to Doug Cook over there. Doug is the candy van man. Always throws pieces of candy in the boxes when he ships you stuff. I love it. But anyway, shout out to those guys. Yeah, so pretty much the last piece of plumbing that I have to do on this setup is for the injectors. So these two fittings right here, and they need to connect to this Y fitting. And I might actually change this slightly. So I'm trying to eliminate as many fittings as possible. And I think I'm going to try to get rid of this one to bring this up a little bit higher so it has, you know, a little bit more clearance. So, yeah, thinking what I could do is probably get because this regulator uses -8 ORB ports. All that is basically a AN fitting with, or a dash 8 AN fitting without that 37-degree taper or flare on it, and it just uses an O-ring instead. So what I'm thinking is maybe just getting a dash 8 ORB to dual 4 AN, so that way I can gain about an inch of clearance. So yep, I don't know, I really got to see how it looks with the 90-degree fittings on here, but we'll find out in a second. So what I got from Motion Raceworks is pretty much some methanol E85 rated hose. This is Fragola. I got 2 straight fittings. Where's the other one? So yeah, 2 straight dash 4 AN fittings, and then 2 90 dash 4 AN fittings. And what I want to do is basically use the 90s right here. They'll shoot upward, and then use the straights right there, because I will have a little bit of clearance in this area right here, even with the plenum in place. And yeah, and then call it good. But yeah, let me finish this line right here. I already got one 90-degree fitting seated on the hose. I got to throw the other one on there and then cut them to length, and then basically screw them on. One thing I will say is I do like using assembly lube when I do this. I'll usually throw it on the fitting threads, so that way they don't gall and then, you know, get stripped. This stuff works pretty good. It's a high pressure type of grease, so it's perfect for what I'm doing as far as, you know, fastening down these threads. But yeah, let me jump to it and get this hose finished, and then cut them to length, and then we'll come back and see what it looks like. So next day, fortunately I was able to get both of these hoses knocked out. I did have to make a slight change on 2 of the fittings for each hose. Basically just had to change out 2 of the straight fittings with 90-degree fittings that go to the injector hats. So that's all good. So as you can see, both lines are connected to each of their injectors that they're feeding. And then lines shoot down. They come down and they go to this dash 6 to dual dash 4 AN Y fitting. And this is basically the feed for each of those lines that go up to the injectors. And then obviously I have my fuel pressure regulator, and then I have a dash 6 line going back to the fuel tank right there. This, I do got to get a clamp for this. Actually the style that, you know, clamps on the hose, and then you could like run a bolt through it. And that's just more so I can keep it secure. This is actually tucked within the fairings of the bike a good bit. You're probably not picking up that good on video, but it's not too bad, so I'm not gonna worry about it. But yeah, it came out pretty good. See in there, that is where the welding is gonna have to be done, because oh, I didn't even show you guys this. Let's see if I can lift this out of here. Oh. But this is a very nice piece that I got from my friend over at Racer's Edge Performance in Arizona. Brett Barber, he makes these really nice billet intake throttle neck flanges for the YZ stuff. And man, when I tell you the machining is like on the money on this thing, the machining is literally on the money. But basically what I'm planning on using that for is basically a neck to build off of. Because initially I was going to put a V-band right there, but I kind of wanted to avoid that because they tend to start getting bulky, especially if you use like the stainless clamps that come with them. So I thought this was a much better option, because if I just hard tube it, you know, and use that as a base to build off of, I could just weld it to the underside of the throttle body right there. So yeah, but anyways, that's a super nice piece. But down here you can kind of see the angularity difference. So we'll have to do like a pike cut, and then yeah, we'll have to do like a custom pike cut, and then weld this, or this will actually end up all being a single piece setup. So whenever this flange is unbolted, the throttle body will basically come off with it, and then the mouth of the throttle body will actually have its own V-band that goes up to the plenum. That'll be in this area right here. So so this is pretty much with all of the fuel system components mocked up. So I'm gonna put some gas in it now, and then I'll go into more detail on the fuel tech, and as far as showing you the pretty cool features of the Moto gadget, and how it can, you know, significantly help when you're you know, setting everything up. So yeah, let me throw some gas in it and go from there. And this is just 93 pump gas, just to run through it, just for testing purposes. Ooh, I got that everywhere. Great. All right, so you guys can pretty much see I got the injectors plumbed, got all this stuff plumbed in down here leading up to the injectors, fuel pressure regulator, or I'm sorry, fuel pressure sensor plugged in. Actually calibrated the sensor in the fuel tech the other day, so now the readings are correct. And then because I don't have my return bulkhead on the tank yet, I just pretty much have the hose running back through the fuel cap, so that's no big deal. And that's coming right there from the ethanol content sensor. So yeah, all right, so something pretty cool about this Moto gadget, M-Unit Blue, which I really like for you know, as far as like setup, like for what I'm doing on the fuel system, is that, let me boot up the app. So this is pretty much like a layout of all of the different circuits that are integrated into the M-Unit Blue. So in my case, I'm actually using auxiliary 2 to power the fuel pump, and that's more so because auxiliary 2 is recognized as two 10 amp circuits, but you can actually bridge them together and use it as one 20 amp circuit. And with this layout, this is basically like a live I guess like button pad, so I can actually click either, you know, either of these buttons right here, and it'll turn the circuit on as long as the system's online. So like in my case, let's see, I'm gonna hit auxiliary 2, and then you'll hear the fuel pump cut on. And then this is like a live readout of the fuel tech right here, so this shows all the inputs and outputs. So turn that off, and then I'm not sure if you guys noticed, it actually gives you a live current reading as well. Hopefully the camera is picking that up, but it's pulling 6.7 amps. So that actually makes me feel a lot better about this pump, because
Mo ride ready.
Up. Yeah, that makes me feel a lot better about this pump, because initially I thought that I was going to have a problem with the pump pulling too much current, because obviously on these bikes we're stator limited. I mean, I do have the higher output WR YZ450FX stator, but you know, they only pull out so much wattage. So but anyways, 6.5 amps, and that's already with the fuel pressure set at 43.5 psi, so 3 bar, which I'll be riding around on 90% of the time. That's not too bad. I actually feel a lot better about the situation now. So yeah, let me start the pump up one more time. You can see that's 43.7 psi, so that's right on the money. Changed that yesterday using this fuel adjustment screw right here. And then obviously you hear the pump pumping. I don't want to get gas everywhere, but you can see it. So but yeah, it's working out pretty good. So you guys can see a live readout of all this stuff. But yeah, this this is one instance where this Moto gadget is really cool, because this makes it super convenient to do stuff like this. Because normally you would want to set this fuel pressure with the pump running, so you would normally have to find a way to make the pump continuously run. But I mean, it's pretty much at my fingertips right here. So really love this unit, highly recommend it. I mean, it does take some know-how to wire this and integrate it into a bike that doesn't, you know, have it. But yeah, pretty nice. But yeah, the fuel system is I'd say is pretty much good to go. Only thing I got to do now is run a return line somewhere up here on top of the tank, because that's pretty much what this line is right here. I just have a makeshift one ran just for the video. I'm actually thinking about doing a Radium Engineering bulkhead banjo fitting, and that'll either be integrated into the cap or integrated somewhere right here on the tank. But it being a swivel is a must. So, but yeah, everything looks pretty good. Is actually that return port right there that I have running up to the fuel cap. So you could also even see, oops, did not mean to do that. You can also see the current draw in amps and watts, and then the current voltage right here at the bottom. So, but yeah, pretty sweet. Gotta love technology. And then obviously we can also test the injectors with this interface also. So let me trigger the pump back on. So 6.6 amps. Got the fuel pressure to rated pressure. I'm on my output map on the fuel tech. You can see the primary injector right there, secondary injector, and when I hit this lightning bolt, it's actually going to trigger this or that injector right there. So you can actually see the fuel misting out the side of the bike. So I'll press it now. That tastes very good. Other one you really can't see as much, but I'll hit this one more time. You can see it. But yeah, it's pretty cool. All right, so just for shits and giggles, I thought would actually be a pretty good thing to show you guys. But as you guys know, obviously I'm running 43.5 psi, or what's better known as 3-bar base pressure for the fuel system. So that's pretty much the set base pressure that the injectors operate at. But one thing you have to be cognizant about is that even though you're running with that set base pressure, since this is a boost referenced fuel pressure regulator, there's a 1-to-1 rise with fuel pressure and boost pressure. So for every 1 psi of pressure in the intake manifold, the boost or the fuel pressure raises 1 psi also. So if I'm running my base pressure at 43.5 psi, the moment I make 1 psi of boost, the fuel pressure basically goes up to 44.5 psi, and so on. So since the current draw was the topic of discussion, obviously the more fuel pressure that is put on this pump in the tank, the AEM fuel pump that I'm running, the more current the pump pulls, because it's working under more load, aka more pressure. So I figure that since I can see the live current draw on here, why don't we simulate as if I was running 30 pounds of boost. And basically how I'm going to do that is I have this adjustment screw right here on the regulator, and as I screw it in, it's basically increasing fuel pressure and putting more load on the pump. So essentially, if I'm running a 43.5 base pressure, if I make 30 pounds of boost with this turbo, the end result would be 73.5 psi fuel pressure. So easy way to simulate that is I can actually turn the pump on using the Moto Gadget controller, and then I could just turn this fuel adjustment or this fuel pressure regulation screw until I reach 73.5 psi on this dash right here. And I hope this is picking this up, but anyway, so I'm gonna turn the pump on so you can hear it running. See the fuel in there, and you see I am at 43.8, so that's close enough. And at 43.8 I am pulling 6.5 amps. I don't know why this won't focus. So let's turn it up. Let's turn this screw right here, and you'll see the pressure rising. And then you'll also hear a tone change in the pump. So you hear the wrench ratcheting, raising the pump. And then you can also see like a linear rise with that current draw. See how it's reading 7.3 amps now? Because the pump is working under more load, so it has to work harder. And that's also why that tone is changing. So alright, this would be the equivalent of 27 pounds of boost right here. It's 27 plus 43.5 is 70.5. And let's take it up to 75. 76. 76.1. 8.2 amps. That's still a lot lower than I would expect to see. So, I mean, I still don't think it'll be a problem at all, even with this charging system on this bike. So, but yeah, once again, another beneficial reason for having this button pad right here, because you can simulate stuff like this. So that's another +1 for this Moto Gadget. But anyways, let's turn this back down. See, we're already down to 62 psi. Put it back to 43. All right, there we go. So, yeah. Now you can see we're back at 6.5 amps. So, all in all, I plan on running maybe around like 25 psi. Honestly, I don't even know how much boost I'll be able to make, but I plan on running as much as I can. That's kind of the purpose for building the motor. But yeah, I just figured I would show you guys that. But there's basically like a linear rise between current draw and the fuel pump load, aka pressure increase. So yeah, guys, so that pretty much wraps it up as far as the fuel system goes. I'm pretty happy with the progress that I've made on everything so far. Only thing I gotta do is just get that bulkhead, like I said earlier. But yeah, for the most part, everything works pretty good. Sensors reading correct. No leaks on the injectors, so happy about that. But I also will be putting together a separate video to go into more detail on this KTM Duke throttle body that I swapped to, because a lot of guys were interested in that when they saw my first Instagram post saying that I was, you know, switching over to that. A lot of cool features you could do with the drive-by-wire stuff. So I want to dedicate a video specifically for that. But yeah, until then, just stay tuned. Hopefully we should have the motor soon. As it stands right now, everything is lining up to where it'll be complete before I get the motor. So it should be a pretty seamless swap once I get it. But yeah, until next time, yeah, just check out my TikTok, YouTube, Instagram. I'll be posting on there actively. But yeah, anyways, until next time, guys, peace.